There is a legend of a two-dimensional land of figures, an infinite landscape filled with circles, wild curves, and polygons of all shapes and sizes. But this story is not about those wildlings. No. Our story focuses on a square. Not any square. This was A squared, the king of the squares. As the sages say, a square is made up of squares upon squares. An infinite number of them, in fact. It so happened that A squared's favorite companion was not the gregarious G squared, nor the party animal P squared, nor the loving L squared, but was instead his princely brother, B squared. It was said that A squared and B squared were inseparable, literally, as A squared carried B squared wherever he went. Until one day, B squared fell in love with a very eccentric ellipse. He loved her so much that the prince tore himself apart from King A squared, thus leaving the king wounded and unwhole. The squares of the land were in shock and without guidance. Their great king had been torn into an irregular polygon. The eccentric ellipse, Tammy, felt terrible for the difference of these two squares. But being a conic of infinite sides, she had wisdom to see something they could not.
Do you not see that this difference has created something beautiful?
She asked the king. King A squared mournfully intoned.
How so? I am no longer a perfect square, but my brother, he still retains his equal-sidedness. Will others follow in his edge steps? Will they deem that it's hip to be like B squared?
Bracing herself along her major axis, the ellipse said,
It's true, King A squared, that when the prince, your brother, B squared, broke from you, it left you not as a regular polygon. But, in his absence, you are proof.
The king guffawed.
Proof? Proof of what?
See here. You could break off these parts to make yourself square again.
She started, but the king interrupted.
And be a lesser square? An A minus B squared? No, I will not live with that shame.
Tammy continued.
But you forget that those other pieces will always be part of you. They may not be the squares of your people, but they are still of your form. They are each B, A minus B.
Now you mock me as part rectangle? You truly are eccentric, Tammy the Ellipse. Your tale of proof begins to bore me, and I believe you are showing some hyperbolic tendencies.
Ignoring the king's insult, the wise ellipse continued.
Do you not see? You are King A squared minus Prince B squared, but you are likewise the sum of A minus B squared, and two of these B A minus B's. Witness as we can factor from this other form of you, A minus B, leaving a conjugate factor, A plus B.
King A squared sat in shocked silence as he realized that his new form truly was a proof of something great. Tammy the ellipse continued.
You are, my king among kings, proof that the difference between two squares is the product of the sum and difference of their sides. Your brother and I shall leave you to rule as proof, not shame. All will believe you to have intentionally made yourself into proof, and we shall not speak of the truth of these moments. Our ellipses are sealed.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. In this video, I will briefly review factoring a difference of squares. So let's get started. The opener to this entire video was a story-based proof of the following theorem. Now you probably notice I don't use A and B like, well, pretty much everybody else. This is for a few reasons, but the most important for you is that I tend to say first squared minus last squared. thus F and L. By the way, if you didn't like my story-based proof, then all you need to really do is distribute out that right-hand side to arrive at the needed result. I personally find a geometric proof to be more beautiful mathematically, and the reality is there are quite a few individuals who are more visual with their thinking. So that is for those individuals. Using the difference of squares theorem is pretty quick and hopefully painless. Let's go ahead and factor 625x to the fourth minus 1. Whenever you have a difference of two terms, it's a good idea to see if each term is a perfect square or in later courses perfect cubes. In this case, we have the quantity 25x squared being squared minus a 1 being squared. F is 25x squared and L is 1. Following the theorem, we get 25x squared minus 1 times 25x squared plus 1. Before calling this done, you need to look at each of those factors to see if either of them is another difference of squares. We can easily see the first factor is a difference of two squares, the quantity of 5x being squared and then 1 being squared. So doing one last difference of squares factoring, we arrive at the following result. There is no theorem that allows us to factor a sum of squares over the real number system, so don't bother trying anything with that third factor. However, if you are familiar with complex numbers, and if your instructor expects you to factor over the complex number system, then you're likely not watching this video because you're in pre-calculus and you should be able to use difference of squares in your sleep. But for giggles, let's just do it. Earmuffs if you're not in pre-calculus. Over the complex number system, that third factor is actually a difference of squares. It's 5x being squared minus I being squared. So this factors to 5x minus I times 5x plus I. And so our complete factorization would be as follows. Again, you would only do this if you are expected to factor over the complex number system. That expectation generally does not occur until you're right before calculus. And to be very honest with you, factoring over the complex number system is really not critical until you're in, of course, like differential equations. Since this is a review video, I think one example is fine. However, I want to showcase something that you likely never thought of when using difference of squares. Suppose you've been asked to multiply the following. I can quickly tell you the answer is 9,984, but you should probably be asking, how did I do it? And you might even be thinking that I grabbed a calculator or spent some time thinking about this. I really didn't. It's very quick to do. Those numbers, 104 and 96, center at 100. The first is 100 plus 4, and the second number is 100 minus 4, which we know by difference of squares is 100 squared minus 4 squared. Well, that's just 10,000 minus 16. To be honest, this cool use of the difference of squares theorem is only useful if, 1, the numbers center at an integer. That is critical because if the center is not an integer, then squaring that is going to be fairly tricky. 2, that integer is easy to square. This kind of jumps back to what I just said, that we'd like our center to be an integer because integers are easier to square than non-integers. But even if it is an integer, it can be very challenging to square, so that's a concern. And third, the distance between the numbers should not be too large. If the distance is pretty large, then again, you're squaring something large and it kind of defeats the purpose of the trick. It's a cool party trick when the numbers are close and the squaring is easy. So you can see in this example, 56 and 44 are centered at 50, and so we have 50 plus 6, 50 minus 6, that's just 50 squared minus 6 squared, or 2500 minus 36. And when I do this, I generally think, okay, 2500 minus 40, which is going to be 2460, and then add back 4, so 2464. You have your own mental math tricks, probably. As a final warning, I just want to mention something that I mentioned earlier, in fact, that there is no sum of squares theorem. So don't try to make one up. This is a mistake that students make early in their academic careers. Please avoid doing that. Enough said. Thank you for watching this short review video on difference of squares. As always, this content should be prerequisite to the course in which you're currently enrolled. If you found this material unfamiliar, or if it was confusing to you, then I recommend you click on the provided relevant prerequisite links listed below for further help. However, if you find you're continually doing this, you might want to consider speaking with your instructor about other course options. On that note, I sincerely hope these videos help you achieve success in your transfer level math and science courses. Cue the music.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much. That isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.